LD is cracked. Let's get into this. Today we're going to talk about the process of photosynthesis. This process is over 3 billion years old, and quite frankly, this is a process that we owe our lives to, our existence to. This is a seemingly simple process that allows plants to take CO2, sunlight, and water and convert them into oxygen. This process is responsible for the production of 30,000 pounds of biomass per second. Biomass, it is a chemical energy, that's sugar, and it's converted from light energy. Plants will take this sugar, it'll take this chemical energy, and it'll store it in their leaves, their stems, in the roots. And through this, it allows it is used as an energy source and a food source for other organisms in the ecosystem. Like, take example, a deer that comes by and eats little berries, or a rabbit that comes and eats some greens. Even though scientists can explain the overall process of photosynthesis, it isn't totally understand in great detail. Like, they don't know the exact causation of photosynthesis. That's still up for debate. There are biologists that believe it is quantum mechanics because the capturing of a photon because of photosynthesis is nearly 100%. The efficiency only really falls roughly 1% if you try to calculate how efficient turning the light into the final product of fuel and biomass is. Now, with the power of the potential of quantum computing, right? If one day we could solve how this process occurs and be able to create it artificially, physicists like Michio Kaku believe the solar age will become a reality. So let's talk about the humus theory. Up until the 1600s, the way plants grew, the belief there was through a process of plants eating the soil. This was discovered by Aristotle, or the idea was created by Aristotle. It wasn't until the 1640s a man named Jan van Helmont, he ran an experiment where he took a 5-pound maple tree and he planted it in a container with 200 pounds of soil. And for the next 5 years, he just added rainwater to this pot, right? And obviously the humus theory believed that the plant grew because of the process of eating the soil. But after these 5 years, he took the tree, he measured that. It went from 5 pounds to 164 pounds. And then he took the 200 pounds of soil and weighed that, and that only lost 2 ounces. So he just accredited all the growth of the tree to the water. Obviously, he didn't know about photosynthesis yet and invisible gases. So he just said, it's just the water that made this tree grow. That's why it gained over 150 pounds. Then in the 1770s came an English chemist named Joseph Priestley. He conducted a more detailed experiment where he noticed if he put a lit candle in a glass jar, it would burn out quickly. But then if he took that lit candle and paired it up with a plant and he closed that glass jar, he realized that flame would keep going, right? And essentially what's happening is that flame is releasing carbon dioxide, which the plant is taking, converting that to oxygen, which then is fueling the little candle, the fire on the candle, and it's just a continuous process. It wasn't until the early 1800s where scientists were finally discovering the requirements for plants to grow, which is, sunlight, water, carbon dioxide, which then gives off oxygen. That's my little talk on photosynthesis. I got the idea to make this video just because I'm reading Quantum Supremacy by Michio Kaku still, and he's just correlating all the benefits that quantum computing could have to the world. And I didn't know the process of photosynthesis was, I know it's interesting, but I didn't know it was still pretty unexplained, just because they don't know exactly how it's happening. And this is a big focal point when it comes to quantum computing, because they believe that it is a quantum mechanic process that's allowing this to happen, and they're interested because how is it happening at room temperature? For scientists with quantum computers to run these quantum processes, they have to get it to just above absolute 0 degrees. They have to cool it all the way down and be just above absolute 0 to be coherent. And to keep these atoms coherent is a feat. Michio Kaku talks about even just somebody sneezing in the room causes these atoms that are vibrating all at the same frequency and all that to become decoherent. So they're just, scientists and physicists are astonished on how could this quantum process be happening at 100 plus degree temperatures in nature, and how is Mother Nature capable of doing that through all of planet Earth, where it's just different variables of temperature. It's not all a constant. Think of in nature what could disrupt this coherence. I mean, if a sneeze can disrupt it, what about an animal stepping on it, or cars, or wind, or trees falling, or anything that you can think of? I mean, they talk about a door shutting, and it causes the atoms to become decoherent. So it's all very interesting stuff. But that's going to conclude the video. Thank you for tuning in. If you have anything to add to the conversation, or if I said anything wrong, or something that you disagree with, or things you do agree with, or you want to just keep the conversation flowing, just add a comment. I like to hear back because I like to have a intellectual conversation and see what people's thoughts are, and just maybe I can learn even more. So if you have any thoughts on the topic, leave a comment, and yeah, I will talk to you guys tomorrow. Peace.